All right, well, we can kind of get started here. There's still a little bit more intro, but for the data sets today, one thing I always do when I go to a new place, I've never been to New Orleans before, is I try to get inspired by like reading a book or watching a movie about the place. So for this one, I watched the Pelican Brief. I had to go there. And, no spoilers, but I went looking for some pelican data, some bird data. Couldn't find any bird data, but I found lots of data on oil and gas, which is also related to the Pelican Brief, which I guess is a spoiler. But that's the data set we're going to be looking at today. A lot of oil and gas data in Louisiana. Now, this may be one of the most important things that we're going to cover in this session. Obviously, this is Dr. Sarah Battersby. I'm Kent Martin, and I'm product manager on the MAPS team. Sarah is a research manager. And we have an important thing that we want to get settled, and we need your help to settle it. It's a little bit of a friendly wager on the line.
This may be the most important part of the session.
It might be the most important part of the session. It is. Who has the best Twitter handle? Now, there's Sarah, who's known as MAPS Overlord.
See, I'm already getting applause before we even vote.
I mean, she may have already won. And then there's me, Data Kmart.
So I think, didn't Kmart go out bankrupt or something?
We don't need to do the vote today. we can work that out throughout the week and have a poll or something, yes.
Yeah.
I think, like usual, Sarah beats me, so let's get started. All right, let me jump out of presentation mode here. I see that things are a little bit messed up. Let me just sort this out. I know there's so many workbooks here. All right. So for this session, I like to start a lot of the stuff that I build from scratch, just so you can kind of see how it goes from the start. And the way we're going to do this session is I'm going to cover basically an exploratory type of analysis, ask a few questions, figure it out, and then I'm going to hand things over to Sarah, and she's going to kind of dive deeper into the topic and the data. So we're going to do that a couple times where I get things kind of started, Sarah's going to take it and go real deep with it. So in this case, as I mentioned before, we're going to be looking at oil and gas data in southern Louisiana. Now this is just from an open data source that I found, and I can bring that in easily by connecting to a shapefile in Tableau. Obviously there's a ton of data, and one of the things I start to think about is distribution and concentration, which Sarah's going to talk a little bit more about. But when you think about presenting data on a map, it's really important to think about your audience. And in this data set, I have a few different dimensions and ways in which I could display the data. So if you're talking to someone who lives in southern Louisiana, you might not show them this map. You may talk about, well, where are the oil and gas wells located, right? And it might make more sense to give them a county name. And in Louisiana, they're called parishes. This data set has parish included in it. I can just double click on that. We'll flip to map. Number of records on color. So what's my question? Where are the most oil and gas wells in the state of Louisiana? Well, they're in Plaquemines. I hope that's how I say it. Plaquemines. I'm not sure. But again, it's about who are the people you're trying to convey this information to, right? If this is the general population, well, this might make sense. I can also notice something about the data, though, that there's all of these parishes in the north of Louisiana now have values, right? And this was a southern Louisiana data set. So let's examine this just for a second. I'm going to go ahead and dual access the data. I'll bring geometry back onto the viz. And we've confirmed something, right? A new question. Should you always blindly trust open data? No, because it's clearly wrong. How do these things have marks? But that's a real thing, right? Open data is a great source for geographic data, for spatial data. We should always examine the data first, explore it, and make sure that it's accurate. Common sense. So yeah, in this case, here we've gone ahead and we're talking about how do we talk to the audience, right? Who is our audience? So if you actually work in the oil and gas industry, like you're in regulation or exploration, maybe parish level data doesn't really make sense for you, right? you might want to work with a specific custom geography like an oil field. So to do that, we have a new question. How can I figure out which oil field in southern Louisiana has the most oil wells? I can go here, and I have oil and gas field data. I'm going to bring it onto the viz. I'll bring field name and ID on just to disambiguate the polygon boundaries. So now I have a data set that might make a lot more sense when you're talking with someone who's in the industry, right? And again, it's real easy to answer my question. I can drag number of records onto the viz, and you can see the color scheme applied. Now, I know because I've explored the data a little bit, but even this is a little bit of a hard visual to pick out because there's so many small little geographies, right? There might be a little blue shape in there somewhere that's hard to pick out. So in this case, I'd recommend using proportional symbols. So I can flip it to proportional. I can drag number of records onto size. I'll bring the size up, and maybe I'll change the color scheme. Sarah wanted me to use LSU purple and gold, but I just think this one looks really nice. So then you can see with proportional symbols, obviously, it jumps right out, right? So this is kind of like a best practice for working with this type of data, right? Really examine how the data looks, and you might make a choice between the filled map or using a proportional symbol. The other thing you can do here is there's a lot of noise on this map too, right? There's a lot of small little oil fields kind of sprinkled all about. Well, you can go ahead and filter out some of that noise to make it a little bit easier to visualize, right? I just take this out a little bit, and it starts to reveal that real concentration closer to the coastline in Louisiana. Now, for our question, we answered it right. Where are the most oil and gas fields, or which oil field has the most oil and gas? It's Garden Island Bay. But that's for a contiguous oil field. I know a little bit about this data, that some of the oil fields are spread out, even though they have the same name. They're just not adjacent to each other. So how do we go ahead and answer that question? I'm going to cover this an important topic, which is you don't always need to use a map to answer a question about geography, right? If you know the question, maybe it's as simple as using a bar chart. So for non-contiguous oil fields, I can go here. Maybe I just want to look at the top 10. I can just bring field name onto filter, and then I can go ahead and sort that by number of records. So I can actually see it's a different oil field, which is the one that contains the most oil and gas data in the region. And I can prove that by removing ID from the viz, which was disambiguating the data. And there I can see it jumps up. I'm actually going to go over here and clear my filter. And there it is. It jumps right out. So again, I've kind of started from scratch, thinking about who my audience is, what's the best way to present this data, and ways in which, of course, you can connect the spatial data, dual access data, to present different ways in which you can do QA on the data set as well. Now from here, I think I've covered the introduction. I'm going to hand things over to Sarah, who's going to examine this data and dig into the topic of distribution. Sarah?
Okay. Sweet. So Kent has walked through a number of different examples of answering some spatial questions about these oil and gas wells. What I'm going to do is take a step back, and we're going to dig a little bit deeper and try and get to some of the fundamental questions behind what he was trying to dig into with his data set. One of the things that I've learned through working with geospatial data for a handful of years is that there are a lot of ways of answering the same spatial question. And how you get from point A to point B gives you a totally different answer. It gives you a totally different way of looking at your data. So I'm going to start out by looking at some basic questions of how the data is distributed, because I think that this is the most fundamental spatial analytic task that you might do. I want to see the data, I want to see where it is, and I want to look at a number of different ways of understanding how it's distributed across space. So we're going to start out just by taking that same data set, and we're going to start binning it. So instead of looking at those raw point locations with all of the individual oil well locations, we're going to aggregate them together. Because the whole cluster of points together is just a little bit too much. So here what I've done is I've created this little square grid. And this is the absolute easiest way that you can look at a distribution in Tableau. So what I'm going to do is I'm going to drop number of records onto color. And really quickly, we're going to have a view that shows us where are the hot spots, where are the most oil wells across this entire distribution. Now, why do I say that this is the absolute easiest way to look at your spatial distribution in Tableau? At least when you've got a fairly dense data set. If you only have 10 points on your map, just look at the points. You're not going to have a problem understanding that distribution. But when you've got thousands and thousands, you might want to transform it. So what I did here is I'm really just rounding the data set. So I have latitude and longitude values. Let me go ahead and zoom in on this. All I'm saying is take the latitude and round that number off. So start truncating the decimal precision. And here I'm using a parameter because I often don't know how many decimal places of precision I want to use. So if I create a parameter, I can just keep dragging it till it looks like I've got the right level of precision. Once I've got that set up for both my latitude and longitude, I put those new rounded numbers onto the viz, and it gives me a square grid. So all it's doing is it's snapping all of those latitude and longitude values to the center of those little square points. I set my mark type to square. I adjust the size until it looks good, and I'm done. Quick distribution. But there are other ways that you might want to look at your distribution. You might want to look at something like hex bins. So hexagons, I think, are a little bit hipper. I like to think of them as, maybe a little edgier. That is probably the best joke that I will tell all day. So there are a bunch of different ways that you can make hex bins in Tableau. We actually have a calculated field, hex bin X and hex bin Y. You can do some super magic calculated field trickery, like densify your data, or you could just use the new spatial intersection feature that we introduced in 2018 too. I created a hexagonal grid in QGIS, which is a free and open source GIS, and I gave you all of the hexagons up there just so you could see that I really just created this kind of big, big region that covered all of my data. I did a spatial intersection in Tableau, and I can drop number of records onto color, and now I can see that same distribution just in a different way. Now I did I did a right join so you could see all of the hexagons I created. If you do an inner join, it'll really just simplify it down to just the area that is covered by your data set. So you can get rid of all that extra crap that you created because you want to make a grid that you know is going to cover all of the possible boundary of your data set. And just to give you an idea of how long that takes, it was probably about a minute and a half to go into QGIS, create my grid, and bring it back into Tableau. So it's a pretty quick process once you know the workflow. Another thing you could do, just like Kent showed, you can always use custom geographies and do your point and polygon spatial intersection there. So I can just drop color on there as well. I can look at the distribution of my data in geographies that matter to me. It may be that you don't want these arbitrary geographies like squares or hexagons, but you really care about school districts or oil wells or some other spatial region that makes a lot of sense for your data. So you can use that for aggregating. Or one of my favorite new features, using the heat map or the density map functionality. So here's our regular distribution of the point locations. All I have to do to get a sense, and this is just going to be an approximate sense of where the densest locations are, is to switch from the automatic mark type to the density mark type. And what that's going to do is give, yeah, that's pretty awesome. That's like the 10-second distribution. It's faster than making square bins. But somebody asked me the other day, so why would I want to ever use something like a square bin or a hex bin when I could just create a density map? Well, the thing is because you can get an absolute count if you're using a square bin or a hex bin. The density mark type is going to give you this approximate, ordinal, more or less value. So you're not going to be able to mouse over this particular area and say, oh, there are 3,000 oil wells right over here. You're going to see the individual mark and say, oh, there's oil well 12441. There are a lot of other wells near it. So it's just telling you a little something different about the distribution. So just to put all of those side by side, you can see that they're each telling you a little something different about the data distribution. And this is something I often do when I'm working with any new data set. I add it into Tableau, and I will probably run off literally 4 or 5 different distributions of the data just to take a look and see, what's happening in there? Are there areas I want to dig in more? Are there things that jump out at me that look really interesting? And I see lots of pictures being taken. This is up on Tableau Public. You can grab it. This too can be yours. It's great for Christmas presents. You know, it's like your family's going to love it. So they're just all. I can give you a link on Tableau Public, and it'll be in all of our slides after the talk. So what if you got a really dense data set and you want to know something about the distribution, but you also have a temporal aspect to it as well? So here I've got a taxi cab data set from New York City. I've got about 900,000 points right here. A lot of data. It would probably benefit from doing a little bit of binning or a little bit of digging into what the distribution is. But I've got some more interesting spatial questions I want to ask with it. So what I'm going to do is we're going to look at how we can look at patterns over time. And you could do this with any of those distribution methods that I showed you. I just happen to be using a heat map because I think it looks really cool. So I have sorted this data down, so I've got a filter on the data set. So over here on filters, I'm just sorting it down, so I'm just looking at the weekend pickups, because I have a really specific question I want to answer here, and that is, what time do the bars close in New York City? Because, it's a really important question. So we just got the weekend, because that's when most people, I think, are going to be staying really late at the bars. And up on the pages shelf, I've dropped this, this dimension of hours. So I'm sorting this data into 1 hour chunks. Midnight to 1, 1 to 2, 2 to 3. And because I've got that on the pages shelf, I can just hit the play button and we can watch the taxi cab pickups change over time. So it's just going to run through a full day and you can watch the density change. And what's cool about what Tableau is doing under the surface is the heat that's showing up on this map is relative to the entire duration of the data set. It's not recalculating it for every time step, which means that we can make an absolute comparison between 1 in the morning and 10 in the morning. So if I'm going to take this back, we're going to figure out what time the bars close. So here's our midnight to 1, 1 to 2, still a lot of people out. 2 to 3, I have no clue what's really happening at this time of day because I'm asleep by like 9:30. 3 to 4, still a lot of pickups. 4 to 5, it's starting to slow down, but we've got some key hot spots and some big bar areas. And then everyone's asleep. I mean, this is when I'm getting up, I'll just point out. So it's like I'm one of those points that's like, getting my cab to go somewhere for breakfast at this point. But it turns out the bars in New York City close at 4. So we can use this to start, answering some new and interesting questions. Another way of digging into data, and this uses the new set actions feature, which comes out in 2018-3. And I don't know if I like this more than heat maps or like the same as heat maps, but it is like so killer awesome that it's just kind of hard to rank them. So I used to get a lot of questions of, I need to know how far X is from Y. How many customers are within a mile? How many of my distribution facilities are within 5 miles of my warehouses? It's a really common question, and I would answer these questions on the forums and be like, okay, you're going to create a parameter, and you're going to create a calculated field, and you're going to strip the latitude and longitude out of your data set, and then you're going to do a calculation, and everybody's like, cool, but can't I just click on the location and get a value? No. So turns out with set actions, I don't think this is what they intended, but you can totally do that now. So I'm going to go ahead and just pick a point. We'll pick this nice Starbucks location. So I'll highlight it right there. I'm going to click on it. My map is going to update. So that little star just jumped down to the point that I clicked on. All of those yellow points are all of the stores that are within my 1 mile search distance. I have a parameter that's controlling that search distance. So if I maybe don't want to look quite as far, I want to know all the stores that are within half a mile, I can just change the parameter and it's going to update how many stores are selected. Or if I want to know a little bit further out, we'll search 1.5 miles, drag the parameter. It's now going to update that search selected. And that selection can then drive any other visualizations. So I'm using that to identify some characteristics of all of the stores that are within the appropriate search radius. And right now I'm just pulling out the top 5 largest stores with employee count and the top 5 closest stores and looking at the employee count. I've also got that set up with a parameter, so if I really wanted to look at, say, the top 10, I could go ahead and change that because I've set this up with a set action. So as soon as the set is updated, it's going to update all of the data that drives my other visualizations. And I'm not going to show you how to build this because I know Kent will build up a little bit of stuff with set actions, and you can download this workbook and pull it apart completely. I think I put in enough comments for you to figure out what happened. If not, ask questions on the forums, and I will answer them, and I will earn points, and I will have a better ranking on the forums.
You're going to beat me at Twitter, then you're going to beat me on the forums?
Oh, I passed Kent on the forums like years ago. But he does have like 6 billion more followers than I do on Twitter, and it might be because he actually tweets things.
I'm going to tweet that right now.
Yeah, go for it. Live tweet our session. And then one last one before I turn it back over to Kent. I want to dig in a little bit more on what happens if you want to know more about what is there. So I've got a little example with some New Orleans bike rack data. So I like to ride my bike around, and when I get somewhere, I like to be able to park my bike, so I thought I'd use that as kind of the base example. But this is something that is really relevant for a whole lot of different use cases. So what I've done is I've set up all my point locations for the bike racks, and I'm hooking it up to Google Street View. So when I change bike rack locations on my map, it's going to load a new Street View image, and I can pan around and take a look for my bike rack. So here they're conveniently located right in the center of the image, right in front of City Hall. But I have all of that Street View functionality, so I can pan around and see what else might be there. Maybe there's a bike lane I want to use. And then I can go to a new location. It'll load the new imagery. And I can check around and see, where am I going to park my bike here? But this is useful for so much more than looking at bike rack locations. I'm going out and I'm trying to look at the 311 data, and I want to know where the potholes are. Street View will show me a view of the street. I'm taking field samples. Street View will show me where all those samples were collected. I'm doing some kind of emergency response. I want to know, what does the street look like for parking the fire truck? Is it wide enough to get through? Anything where it would be helpful to have a Street View image or an aerial image, you could use one of the other Google services. You can load that up and just link it to the viz with the latitude and longitude in your data set using the Google Maps API. This workbook's also up on Tableau Public. I'm not going to let you download it because it uses my personal API key, and if you all started doing that, I think I would get some charges on my credit card. But I did put the code that runs it up on GitHub. You can download that, drop your API in where it says your API key here, and run it yourself. So with that, I'm going to go ahead and turn it back over to Kent.
Thank you, Sarah.
I'll switch you back over.
All right, great. Yeah, Sarah's starting to talk a little bit more about use cases. And so I want to take this time to cover a specific use case because it's obviously something that makes the news every time it happens, right? And that's hurricane and tropical storm data. So I've had a number of customers who work across a number of industries asking about, well, what's the best way to build a visualization that looks at the impact of a storm? And so, I started to think about, well, what's possible, right? Like, what can you connect to in Tableau? How can you do some analysis that's based on some spatial data? And so I'm going to, again, walk through sort of ways in which you can work with some open source data and then hand it back over to Sarah, who's going to go a little bit deeper with this theme. So again, a lot of the data that I'm going to work with is open and available, right? Anyone can go ahead and pull down these data sets and do the analysis for your organization or answer questions that are relevant for your company. So again, here I am at the NOAA website, and I'm just pointing out one thing. You can go and download a shapefile. Tableau knows how to read them. Every storm that's in the world that's monitored, I mean, they're all monitored. This data updates every 6 hours. You can go ahead and pull down the latest data whenever you like. So let's do that. I've pulled down the data, and here I'm looking at, that was Michael that I had the NOAA data up for, but this is Hurricane Florence that hit the Carolinas earlier this year. I can go ahead and bring on percentage and explain what this actually is showing. These zones on the map are just wind probability zones. So the areas in the middle, high likelihood of having hurricane force winds. Areas on the outside at this particular time having a low probability of hurricane force winds. So if I want to look at the impact of the storm at this particular moment in time, I might consider the population that lives there in the Carolinas, right? And to get population data and a fairly granular look at the population, I'm going to go to the census and download census tract information. So I can jump back to the browser. The census has a great download website in which you can get any number of really interesting custom geographies. In this case, I said I'm going to work with census tracts. I'll hit submit. And of course, I could go ahead and choose South Carolina. I've already gone ahead and downloaded South Carolina, North Carolina, and Virginia for the sake of the demo, so we don't have to watch the download. But it's that easy. Go to the site, download the data. Now, the other thing you're going to need is the actual demographic or socioeconomic data, right? So I'm just going to cover it here real quick. Again, part of the census, you can go to the American Fact Finder website and basically filter this data and search for it, saying my browser has been open for too long. You can go in here and add any filter. So I might add a geography filter to say, only look at census tract level data for the Carolinas, and then go search for a variable like, what is the population distribution by age, and download that, which I've done. So let's jump back to Tableau. And my question is I want to analyze the impact of the storm, right, by vulnerable age groups. So I'm going to consider the vulnerable population to be those that are under 5 years of age or over 65. That's not a real definition of vulnerable, but that's the one I'm using for the purpose of this demonstration. So how are we going to bring census level data, which is a shapefile, and match it up with this storm data that I have here on the screen? Because census tracts are boundaries, right? And if I want to work with the census level data that I downloaded, I have South Carolina, North Carolina, and Virginia, which are 3 separate shapefiles. So a couple of things, right? Tableau doesn't support the union of spatial files, so I'm going to want to merge those data sets together to create one table. And if you're going to use intersects as a way to match these 2 tables together, to join them, well, in Tableau, we support point and polygon joins, so a boundary and a point. And to do that, I'm going to need to turn those census tracts into points by generating their centroids or something like that. So I'm going to show you how I would do it. Here we are in QGIS. This is what Sarah mentioned earlier. Free and open source GIS software. Very good for doing, any number of spatial operations on your data or transformations if you need it. So again, I downloaded the census tract data for each state. You can see they're separate tables. If I want to merge them into one, I can use a tool called Merge Vector Layers. I can bring it up, select all the layers that are in this map, and hit run. It takes just a few seconds. And you can see now I've got one table called merged. Great, so now I have that polygonal data set, one table. I can join these 2 together. But of course I mentioned they need to be centroids, right? I can't join polygon and polygon via the spatial operation in Tableau. Not yet. So if I go in here, I can say polygon centroids. And I'm going to use that merged layer. It's called merged. I can just hit run. And now I have all the point locations for all the census tracts in these states that I'm interested in. So if I jump back to Tableau, let's go ahead and bring this data together. I can look at the Data Source tab, and I can see how I've made these connections. Here's the wind speed, the wind probability shapefile. The join in this case is using the spatial intersection. So I'm going to join all those points of the centroids into the actual zones in which they fall. And then the other data set here is that ACS data. So I've actually brought in that demographic data related to age so that I can create a field about a vulnerable population. Okay, so I think we're on the same page. Let me jump back to the sheet. So with this join data set, I'm going to go ahead and just enhance the visual to show the census tract locations and give you a sense of the population as well. So again, I'm going to use a dual axis map. I can pull these off the viz. I'm going to go ahead and bring on my census points, flip the circle mark type. I'm going to add the GeoID to disaggregate the data, bring percentage back on the viz, and then I'm going to go ahead and add vulnerable population to size. this case, I'm going to edit the size as well, just to set the lowest level for the proportional symbols to be a little bit larger number. That way it makes it easier to see where the large population centers stand out. Increase this just a little bit, hit dual axis. Okay, so just in this view, excuse me, again, I get a good sense of where the populations are located, although it's not completely precise because we've taken the centroids, so we're kind of simplifying the data a little bit. But if you wanted to start answering that question about, well, where's the vulnerable population, or what parts of the population are going to be impacted, I think this is a pretty good starting point. But let's answer the specific questions and look at the actual age ranges and age cohorts that are within the data set. Here I'm going to go ahead and bring percentage and vulnerable population onto the viz. Fit height. I can just drag 5% up here to the top, and I'll change my color scheme by using vulnerable population. Yeah, that looks pretty good. And then if I want to look at, so again, this is just basically the same representation of the map, right? I'm looking at the wind probability zones, the percentages on the left, and basically the vulnerable population that is within that zone at this particular time. And then I can also create a graph that allows me to specifically examine the age cohorts as we do comparisons against each other. So let me just build this out a little bit, and I'm going to show you how I use set actions to be able to look at and compare which part of the populations are actually impacted by the areas that I'm looking at on a dashboard. So I can go ahead and bring, let's see, measure values onto the viz. I'm going to take off the fields that I don't need to work with, these area fields, and then my 3 age fields that make up the vulnerable population. That's redundant. And I'll bring the vulnerable population to be the first bar on the viz. Now, if I'm going to use sets to do a comparison, I need to have a set, and here I have one already built based on wind probability, and I can drag that to color. I'll move the in to the lower side, and now let's bring all this data together on a dashboard. It'll start to come to life. All right, let's move our map on here. Let's move our vulnerable population view and our age cohort comparison. Okay. Now, one thing we can do is filter data. Everyone knows we can filter data. I can go ahead here and choose any one of these bars, and it easily filters all that stuff out, right? But I don't want to filter data. I want to be able to make this comparison to the area which I'm looking at, the probability area, against all of the other probability areas. And I want the bars to stay in the same position, right? I want to fix them so I get a sense as I change the data, whatever I'm interacting with, how it compares relatively. So if I go back to, or if I select my map chart and pin it, right, now I want the bars to move up and down, and I can get a sense of how it relatively compares as I make different choices. But again, I said I don't want to filter. I want to actually use the set to determine and be able to compare using the age cohort compare sheet. So here I'm going to go to the dashboard actions, hit add, and here I can say change set values. Again, this is available in 2018.3, set to be released next week. And I'm going to say on selection for data that's using this data source, update this set. And if I unselect, you can just remove everything from the set to get me back to those gray bars. Okay. Let's see how it works. It's not, there we go. That one was already selected. So now what's happening, right? If I go up here on the map, again, it starts to look really interesting. I can select multiple sheets, and I'm able to do that part of the viz which I've selected and compare it against the whole thing. For any of those data viz kind of geeks out there, this is proportional brushing, right? I can easily see how it works just by controlling the set membership through this action. So I think that's a really powerful way to analyze the data. And if I select off the viz, again, it just resets. So I think that's where I'm going to drop or I'm going to stop here, going to hand it back to Sarah, who's going to use SQL Server and some other things to look at how you might analyze data as it relates to hurricane impacts. Thanks.
3. Cool. Okay, so since we're in New Orleans, we're going to do like a little Emerald Lagasse and turn it up a notch. And I'm going to take the example that Kent used looking at how census tract centroids interact with the areas that might be impacted by hurricane or tropical storm force wind. And we're going to look at a little bit deeper bit of analysis. So I'm going to take the census tracts as a polygon and work with them compared to the hurricane or tropical storm force wind probability polygons, which is something that you can't natively do in Tableau right now because it involves a polygon to polygon intersection. But turns out, was it 2018-1? 2018-1, we introduced support for geometries natively from SQL Server Spatial. So I was sitting in a hotel room one night, happened to be at a big geointelligence conference. And what do you do at night when you're at a geointelligence conference? You make disaster visualizations. So I started exploring and downloading some data, and I grabbed the same sort of data sets that Kent had, and I threw them all into SQL Server. And then I started playing with them in Tableau. I'm going to show you the data sets that I'm working with and what new doors that opens in terms of doing some advanced analytics in Tableau. So I'm using pretty much the same data sets that Kent worked with. I have a whole lot of data from NOAA's Hurricane Center. So these are, I think I have, let's see, how many do I have here? I have 6 different data sets that I've unioned together because they put out estimates or forecasts every 6 hours. So I have 6 of those lined up. And Kent mentioned that you can't union spatial files in Tableau. If they're coming from SQL Server, you can. So I've taken multiple different time steps of data that I loaded into SQL Server, and I've unioned them all together in Tableau. And what that actually lets me do is I can look at the time series of how the storm is impacting the population at different times along the forecasts. So I've got those lined up. I have a set of attributes from the census. So just like Kent showed you grabbing data from ACS, I have all of that. And then I have another file that I threw in there, which is just a link between the FIPS code, which is a unique identifier for county IDs, and the name of the county, because we're going to look at how the storm impacts counties as well as census tracts. So what that data gets me, it actually gives me a number of different geometries. So I threw all of this data into SQL Server, and I used some of the analytic functions in SQL Server to process the data. So pretty much anything that you can do with spatial data, you can do in SQL Server. So I actually did a polygon-to-polygon spatial intersection with the data in SQL Server and then returned that geometry so that I could use that geometry in Tableau. So the processing didn't actually happen in Tableau, though I could have triggered it using a custom SQL. I did it as part of this workflow in advance. And I wrote a Python script that just, as soon as I grabbed a new data set, I run the Python script, it spits it into SQL Server, it does some magic on it, and then it's ready to reload my data in Tableau. So it gives me these 3 different geographies. I've got my storm polygons, I have my census tracts, and then I have these partial census tracts. So let me show you what these are. So I've got the storm impact areas. This is the same data, it's just a different time step than what Kent looked at. So we've got the % likelihood of tropical storm force winds in any location. And then we have these partial census tracts. So this is the result of intersecting all of the tract polygons with those storm polygons. So now I have every census tract, and I know how it's impacted or likely to be impacted by the storm, but I have it at a finer granularity than if I was working with census tract centroids. The centroid gives you an all or nothing. Working with the polygons and doing the intersection means that I can actually crack the geometry on those polygons, and I know here's one census tract right here. Part of it is impacted 60 to 70% likelihood, and part of it has a 70 to 80% likelihood. So if I want a finer granularity in any of my calculations, I can figure out how much area is in each one of these partial bits of the census tract, and then proportionally allocate my population or any other attribute based on the percent of the polygon that falls into each of those likelihood of tropical storm force winds. So that gives me a little bit better granularity in terms of doing analytics to assess the impact. So using that, I put together a couple dashboards that I thought were going to be fairly likely of the sort of thing that I might see if I were putting together something for an emergency operations center, or I wanted to put together something to help the public understand what the potential impact was of these storms. So the first thing is just looking at the impact areas. So I've put together the storm polygons and a vizzes tooltip that gives me a little auxiliary information. So when I mouse over any of these polygons telling me the likely of hurricane or tropical storm force winds, it's going to give me an inset map that shows me what counties are impacted. So that's not something that was actually in the original data set that I used, but I am pulling out the county identifier from the census tract ID. Using that vizzes tooltip, I can see the area that's impacted on a county level, and then I can get some additional details about them. Right now, just to show that it's working, I'm just listing off the name of the county, but this could be all sorts of different measures. You might have it list the emergency operations contact for every county. You might have it list the number of shelters that are available in each county. Perhaps each of those are a pie chart that show you what percent capacity is each of those shelters in the counties that are impacted. So
what about Waffle Houses?
You can have Waffle Houses. I know Kent is really big on the Waffle House, and you may kind of laugh, but how many of you guys live in like a hurricane impacted area? Okay, how many of you know about the Waffle House Index? Yeah, everybody who lives in a hurricane area knows about the Waffle House Index. It is literally something that FEMA is going to use to assess how much damage there has been. Because if the Waffle House is open and serving a full menu, everything is good. If the Waffle House is open and serving a limited menu, there are some problems. If the Waffle House is not open, there are a lot of problems. And it's actually a really good index, because if you've never seen a Waffle House, I will describe them to you. They are these little cement-like bunkers that happen to serve really tasty breakfast 24 hours a day. So the Waffle House Index could totally be built into this viz, so long as you have the data for it loaded up in your vizzes tooltip. You could also start digging in some more complex analytics. So this is a little bit more similar to what Kent was building up, except it's based on the tract level data instead of the census tract centroid data. So here I have both the tropical storm force wind speed probabilities and all of the census tracts being rendered on a dual axis map. And I've colored and coded those census tracts so that you can see the relative population count in each of them. I'm going to go ahead and simplify this down just a little bit. We'll keep only a certain number of them. And now I've got a bunch of visualizations that'll give me some summary statistics on these impact areas. So I know exactly how many people are impacted in each one of these storm regions based on the likelihood of impact from the tropical storm force winds. I can break that down by racial characteristics that I grabbed from the census. I can also break it down based on the vulnerable population. If I wanted to, I could build in a set action just like Kent did, and we could see part versus whole relationships for any of these as we interact with the visualization. Could also put together the quick KPI for this. So maybe this is something that's going to be up on the Emergency Operations Center, just the screen that's shown at the front that just gives you, here's the update of what's going to be happening in the next 12 hours. So it's the exact same data. We've got our storm impact zones, we've got our census tracts, and it's just going to give us these quick summary statistics. So I know on September 12th, the midnight forecast, they were predicting for these areas 4.9 million population impacted. That's 64 counties, 2.4 million households, and 2.9 million housing units. So we can get those quick summaries. And I went ahead, since I'd unioned together a bunch of different tables from SQL Server, we can actually watch that change over time. So as I scroll through, and I'm just changing a filter here that's changing which time step I'm loading, we can watch the track of the storm change, and we can watch all of the values that are associated with the polygons that are impacted update. Now, you probably wouldn't be, watching maybe you wouldn't be doing the time series in the EOC, you'd just be looking at, tell me what's coming up now. But if you wanted to do analytics over time and you've got polygon-polygon interactions, you can build all of that up together just running it through SQL Server. So this is a workbook that I can't share with you because it does run off of SQL Server Express on my laptop. But I do have, I've written up I've got a bunch of PowerPoint slides and documentation that I can share with any of you guys if you email me. I can even give you the Python script that I use to take the data and shovel it into SQL Server and do some of the intersections and some magic behind the scenes. Happy to share all of that with y'all. And with that, I'm going to turn it back to Kent to show a few more examples.
All right, we're in a good position here. We got about 15 minutes. And I remember asking Sarah, can we show some of the cool new stuff that's coming? Like, can we just devote some time to some cool new things that maybe people haven't even seen before, which usually always generates some interest. So one of the things that I think is really cool about what is possible in Tableau now is through this whole idea of extensions. So if you watched this morning's keynote, you heard about the developer program and new ways in which you can extend Tableau. There's a number of extensions already in the gallery related to all kinds of things like write back and new visualization types like Sankey diagrams. That are all just drag a web application or the extension onto your dashboard and it just works. Well, I know there's a couple of extensions that are coming related to mapping that I got my hands on, and I wanted to give you a sneak peek. So in this case, I have an extension that I'm going to show that looks at aggregating data, right? Aggregating it quickly and in a number of different ways. This extension was built by Mapbox, and it will be made available in the gallery at some point soon. I'm not sure exactly when. Well, let me show you how it works. I can bring the extension onto the viz. Then I got to choose from my local set of extensions. So pick that T-Rex file. That is the greatest file name extension I've seen in a while. And immediately it's going to take this data on traffic volume that I have for the city of Toronto, and it's going to start to aggregate the data. In this case, it's using a cluster mark. So it's actually clustering the data and showing you a value based on what's been configured in the extension's configuration pane. So here in this case, I'm going to say the data I want to look at is actually maybe vehicle volume. Let me just tab down here. And you'll see the clusters update and the numbers update as well. I can choose from a different map style. But for clustering, I can choose, again, square grids. And like Sarah was showing before, it's a lot like the hexagon example, right? This isn't like rounded latitude and longitude where you might want to scale it depending how you zoom in or anything like that. This is actually based on a distance. And you can see the grid radius here. I can go ahead and adjust that just through this simple UI. And it updates right away. I could choose hex grid. I could choose Voronoi. So Voronoi diagrams are interesting because they give you polygons whose centroids are equidistant from each other. And they group them all and make this sort of tessellated surface. Now, if you're looking at something like cell phone coverage from cell towers, you might use this kind of tessellation. If you're looking at the spread of a disease in some places, you might look at what's the largest area where there's no other known cases of the disease and where is it concentrated. Again, just a way in which you could look at that kind of data. I'm going to bring it back to use, let's keep it edgy and use the hexes. I know, I wasn't looking for laughter, Sarah. I'm talking about Twitter followers. That's all I want. And then down here, again, just a number of other options that you have in the sheet. There's also an extrusion property. And if you know what extrusion is, well, hit the awesome button, and you can see it. So you actually get a 3D view complete with the navigation required to really visualize 3D data. But again, it's like immediate binning. Extrusion, again, is useful so long as it's, I think, interactive and allows you to make relative comparisons as you navigate the data. But it certainly gives you a sense of where the traffic volume is highlighted, along with the dual encoding of the color. So I think this extension is really cool, really powerful. And again, it's still in progress. So if you see the Mapbox folks down in the data village, go chat with them about it. And I know they're giving a session on this kind of extension and other things that they're looking at building I think the session is called Back to the Future with Mapping in Tableau, so go check that out. Now the next thing I want to show you is this extension here. Now, have you ever wanted to work with a different projection in Tableau? Now we know when you work with projections, a projection can distort a map in 4 different ways: shape, area, distance, and direction. And depending on where you live, well, Mercator is going to really butcher some of those places, or some of those properties of the map, right? This is the classic, how is Greenland bigger than Africa situation. Well, coming soon to Tableau 2, friends of ours at DataBlick and Star Schema, partners of Tableau, have built this extension that basically wraps D3 capabilities and the support for projections inside of the extension. So let me go ahead and configure it. I'll try to configure it. I'm going to choose, so I got to walk through their UI here quickly. You'll certainly have a chance to play with it if you download the extension. Country code goes over here. No, it doesn't. Country code goes on dimension. And I'll put country onto geoname. And then I'm going to pick a measure that's in this data set. Let me just pick GDP. I'm going to hit next, next. And then you can get a choice of the projections that are supported. And what's cool about this user interface, again, I could just play around with this. The green circles here on the preview are actually showing you how the map is distorted. So it gives you a sense of, well, where is there going to be maximum distortion, and what's the best way to represent this data for me. So I'm going to go ahead and pick the equal Earth projection. It does a good job of sort of restricting distortion over most of the world, except along the edges of the map. Clearly, it's just straight up cut off. Now, it's showing real small here. That has something to do with PowerPoint. You know, when I switched out of the PowerPoint presentation, it shrunk down this viz, and I don't know why the extension doesn't handle it, but I have a couple of other vizzes built. Let's see if they render properly. Let's see if I can refresh this and make it all work nicely. There we go. So one of the other examples I wanted to show, again, we talked about 3D with extrusion. Well, here's a 3D globe that you can spin around in Tableau. And you can actually interact with the data. And again, you could build up this whole visualization and have it be completely interactive. I mean, have you ever seen a spinning globe in Tableau? That's pretty cool. So here's one example of this extension I just wanted to show. Again, it's going to be worth just playing with it and even submitting some other future requests for this kind of extension. I think they're going to open source it as well. So if you wanted to build even more interactivity in it, customized to how you want to use it, maybe you don't want all of those projections available, right? That's the power of these extensions, especially when they're shared amongst the community. You can go and edit it for your needs. Now, we're almost at the end of time, but I wanted to show you just one more thing related to set actions, because set actions really does feel like a magical feature, right? I showed sort of a simple comparison type of use case using set actions. Sarah showed a distance measurement using set actions. Well, I want to show just one more that allows you to do interactive drill down on a viz. So people often ask, how can I traverse a hierarchy of geographic data inside of Tableau? Well, with set actions, here's an example of how it might look. I can drill in, and again, now I'm just like filter and drill to the lower level of granularity. We didn't have to build a number of like geographically aware features to do this. It's just controlling attributes using set actions. I mean, this is a little bit complicated, I'll be honest with you. There's a little bit of calculation and data preparation that goes into some of this. But you can create this kind of experience that I think is highly useful, and I know is one that a lot of customers have demanded. So that's a little bit of a preview of some of the stuff that's coming. I hope Sarah and I covered a number of things that fit into the intermediate bucket, and I want to thank everyone for coming out to our session. Thank you.